So the question is, how did this line right here result in showing us the value 1, 2, 3? What's happening? Right? Is that the question? Right. Yes, Mike.
You didn't declare an array, but the statement memory location makes it an array of one integer.
No, not one integer, but unknown number of integers to begin with. So let me clarify.
It could be longer.
Let me clarify. I don't know just yet. Let's talk about it. This declaration right here, this declaration of an integer. Just again, let me make sure that I'm recording this right. So.
Maybe you should say that.
I did. It's saving it. So we have memory, right? We have this memory. Okay. And we pretend that this is an endless or unknown size block of memory cells. So we know there could be a lot of things located in this memory. Agree? Okay. We say that our programming language tells us that this is the syntax to use to access memory. One of the syntax possibilities anyway. And what it says is this. Starting from the beginning of memory, remember what I did here was that I declared memory as 0. Okay? That's the way I declared it. And so then we say somehow we obtain address of value. And then we say that as a result, essentially, by saying memory location, we are specifying this memory square brackets location. This type of syntax basically sends us to that particular offset from the beginning of memory. Of course, there is 1, 2, 3 stored in this memory, and there is an integer. In other words, we pretend that our memory at this point is an array of integers. And we go to integer number, 1,356,204 and say there should be an integer there. And so the syntax using square brackets says extract that integer from memory and submit it to cout, so that cout can access it and obviously print it. So essentially that's what's happening.
So there's a null character at the end of int value 1, 2, 3. There's a null character, so that it knows.
No, there is. The integer is simply recognized here on 32-bit architecture as 4-byte size. With integers, the size is known.
How does it know that it's at the end? That it's not 1, 2, 3, 4, 5, 6, 7, 8, 9?
Because internally in those...
There's an end to it.
Internally, because... Okay, good question. We can go to our calculator, right? Switch to like programmer mode, right? And we can say, all right, we have this integer 1, 2, 3, and I'm using decimal. And let's switch first let's switch to a byte. So if integer was the size of a byte, then if I switch to a binary, this is the way it's stored. 1, 2, 3 is stored in a binary form as in a byte as this.
1, 2, 3, 4, 5, 6,
there is actually 1 0 in front of it. So if I switch to double word, which is 32-bit quantity, you should see it right here in a smaller print. This is like 32 bits in a row, and 1, 1, 0, 1, 1, 1, 1, with all the rest zeros, is storing number 123. If this was a different number, say, clear this, and we store some other number, I don't know, something like that, if that's okay, and if I now switch to binary representation, I don't know if right there it still fits. So I have this combination of zeros and ones. So there you go. It's just the internal storage of integers that permits to store these values in exactly 4 bytes.
It's going to take that much memory no matter what integer, and that's
Exactly.
the limit of the size of the integer.
Absolutely. The data type obviously gives us the limit. What is the maximum value? What is the minimum value in terms of negative numbers?
Approximately how big can an integer be?
I don't remember it from the top of my head, but we can go to reference side.
I thought it was real large, like 1,200,000.
There is a system header, what it's called, like a locality, which will be able to tell you what is the allowable range of integers, doubles, and other data types.
And it's taking care of that for me by saying connecting the 32 bits, 32-bit, 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 all this goes with this one integer.
But I would like to clarify, however, that in this particular case, when we say go to this location, we're asking to access only one integer in memory, not collection of integers, just one integer. So there's your zeros and ones right here stored and representing number 123. But this is 4 bytes on 32-bit architecture, or it could be 60. It could be on a 64-bit machine. It could be 8 bytes.
Right, but so really what I'm saying is, if you just made the number bigger, made the number 1,000 instead of 123, the integer, it won't fit.